All right. Hi, everybody. Today we are going to jump into complex solutions to quadratic equations and complex numbers and what they are and how they work and what they do and kind of why we need them. This is sort of a little bit of a jump up from where we were, and we're going to have to kind of be a little bit flexible about how we're doing these problems. So just get a little bit prepared for that. Today's the only day we're going to spend time on learning target 4D. At least this unit. You're going to see this stuff again next unit, but it's going to be in different learning targets. So this is sort of your one-stop chance to do really well on this learning target. Of course, I will make it possible for you to improve your score if you need to do that. Okay, so the reason I'm teaching this lesson is because we look at this equation that's on this side right here, and we're like, I feel like I should be able to get answers for this equation. But remember, if we're looking at these equations and it says equals 0, what we're really doing is we're trying to figure out where does the graph of the parabola cross the x-axis, and the x-axis is right here. And so I notice that this parabola does not cross the x-axis. So I'm just going to write doesn't cross the x-axis. And so my first instinct is, well, I'm just going to use the quadratic formula here just to see what happens when I do this problem. So I'm going to do x equals negative, so a is 1, b is 2, and c is 2. So x equals negative b is 2, plus or minus the square root of 2 squared, minus 4 times a, which is 1, times c, which is 2, all over 2 times a is 1. Okay, so let's do a little simplifying here and see what we end up with. So we get x equals negative 2 plus or minus the square root of 4 minus 4 times 1 times 2 is 8. X equals negative 2 plus or minus the square root of negative 4 over 2. I just want you to take a second. You can just pause the video while I do this. I want you to put the square root of negative 4 into a calculator somewhere. See what you get out. And you should have gotten some kind of error, and it should have said this number doesn't exist or not real or something like that. And so now we need some way to come up with an answer that we can actually write instead of writing this, because this is not real. And because of that, mathematicians were like, okay, well, we need to figure out a way to show that we just took a square root of a negative number. And so they came up with this thing that says I. I stands for imaginary. Isn't that nice? The word imaginary means it's not real. It is made up, but it's a very real thing when we can work with it. So the cool part of this is now, instead of writing the square root of negative 1, I can just write I. So if I wanted to work with the square root of negative 4, like we did on the last problem, I could split this up into two square roots. I could say this is the square root of negative 1 times the square root of 4, because negative 1 times 4 is negative 4. And I know that the square root of negative 1 is I, so I can write I, and we usually write it in kind of cursive, but you don't have to, don't worry about that too much. I times, and then I know that the square root of 4 is 2 because 2 times 4, or 2 times 2 is 4. Okay, so then we could rewrite this as 2I, because we usually just write the letter second. Okay, by the way, if you square both sides of this equation, so if you multiply both sides by I, you end up with this. And so this is a really important property that we need to know. So we need to know both of these things. Number 1 is this, and number 2 is this. Okay, so now we know what an imaginary number is. This part right here is an imaginary number. This part right here is a real number. This is like our normal numbers. And so if you have a part that's a real number and a part that's an imaginary number, we call this a complex number. And we can say that complex numbers have a real part and an imaginary part. So this is the real part, this is the imaginary part. An example of that would be 12 minus I times the square root of 7. So 12 is the real part, and negative I times the square root of 7 is the imaginary part. So the reason I said this is a complex number is because we talk about solutions to equations like this having complex solutions. Complex solutions mean your answers look like m plus, what did I say? Yeah, I think it was m plus ni. Okay. This happens when the graph of the parabola doesn't cross the x-axis. And so what I mean is, here's your graph. If your parabola looks like this, like the one that we saw earlier, or it looks like this or something, and it does not cross the x-axis right here, then that means that you're going to have complex solutions. So your answers are going to look like this. Okay, so I'm going to do a couple of examples, and in the middle of the examples, you're going to have to try a couple of these, but let's try to solve some equations that have complex solutions. So let's start with this one. What I'm going to do is I'm going to start by subtracting 9 from both sides, and I'm going to end up with x squared equals negative 9. And so now let's rewrite. We have x equals plus or minus the square root of negative 9. This is sort of just what we have been doing. But here's the thing. Now I know that square root of negative 9 is the same as the square root of negative 1 times the square root of 9. Okay, and so now what do I have? Well, I have I, because the square root of negative 1 is I. I times, and then the square root of 9 is 3. So now what do I have? I have x equals I times 3. We usually write x equals 3i just because it looks nicer and you don't have to have the multiplication symbol there then. And this is just looks more like a something that we're familiar with. But this is our answer. But you know what I just lost? I lost this plus or minus. So I have to have a plus or minus throughout all of these. So I could also write this as x equals 3i and x equals negative 3i. That's what this plus or minus means. Okay, let's do one more. This one is in vertex form and I can still solve for x. So let's add 8 to both sides. We get negative 1/2 times x plus 1 squared equals 8. Let's multiply both sides by negative 2. I'm choosing negative 2 because I know that negative 2 times negative 1/2 will give me 1. And so now what do I have? I have x plus 1 equals negative 16. Oh, I lost the square. Okay, now let's rewrite x plus 1 equals plus or minus the square root of negative 16. And negative 16 is the square root of negative 1 times the square root of 16. The square root of 16 is 4, and so now I have plus or minus 4 from here, and then this is I. So my answer is x plus 1 equals plus or minus 4i. I'm not quite done yet. I need to subtract 1 from both sides. So I get x equals negative 1 plus or minus the square root, oh, just kidding, plus or minus 4i. There we go. Just going to kind of separate these a little bit. Okay. I want you to try this one. Okay, so I'm going to subtract 32. And I'm going to say, okay, 2x minus 2 squared equals negative 32. Divide both sides by 2. And again, we have this negative 16. And so if I rewrite, I have x minus 2 equals plus or minus the square root of negative 16. Well, we already have seen the square root of negative 16. And so we know that the square root of negative 16 is 4i. So x minus 2 equals plus or minus 4i. And then let's add 2 to both sides. There we go. There's our answer. Okay, this one, I'm going to use the quadratic formula. Okay, there it is. Let's do this one. A is 9, B is 6, C is 5. So x equals negative 6 plus or minus the square root of 6 squared minus 4 times A is 9, C is 5, all over 2 times 9. Okay, so what do we get here? X equals negative 6 plus or minus the square root of 6 squared is 36. 4 times 9 is 36. 36 times 5, I'm just going to use my calculator here. 36 times 5 is 180. All over 2 times 9 is 18. Okay. Okay, so now let's do 36 minus 180. That is x equals, so let's rewrite. Negative 144 over 18. And then, okay, well, 144 is 12 times 12. And so we can rewrite this as x equals negative 6 plus or minus I times 12 over 18. I noticed that 6 goes into all of these things, and so I could rewrite this as x equals negative 1 plus or minus 2i over 3. You can take everything in sight and divide it by 3, and so that's how by 6, sorry, and that's how I got to this. I'm totally fine with you solving and keeping it like this. Either one of these is just fine with me. Okay, I'm going to write the quadratic formula on here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that fraction bar goes all the way underneath the negative b also. Okay, you do this one first, and then I'll go through it. Okay, here I go. X equals negative 6 plus or minus the square root of 6 squared minus 4 times 5 times 2 all over 2a. A is 5. Okay, so x equals negative 6 plus or minus, again, 36 minus, okay, 4 times 5 is 20. 20 times 2 is 40, all over 10. X equals, okay, negative 6 plus or minus 36 minus 40 is negative 4, all over 10. The square root of negative 4 is the square root of negative 1 times the square root of 4. And so we know that this is I times 2. I'm just going to write 2i all over 10. I noticed that all of these numbers are even, and so I could divide everything by 2. So x equals -3 plus or minus I over 5. Either one of these is fine with me for your answer. Just a quick reminder, most of these problems you will be using the quadratic formula for. Make sure you're in standard form. Ax squared plus bx plus c equals 0. Okay. Just to say this, it's not going to work to use factoring if you have a complex solution. So if you look at the graph of your parabola and it doesn't cross the x-axis, then don't try to factor it. Okay, so that was kind of the first part of the lesson. The last part of the lesson is just working with complex numbers themselves. And so we have to be able to add, subtract, and multiply them. We're going to skip dividing. Okay, so adding and subtracting is kind of like just combining like terms. So let's just look at all of the real parts of this one and look at the imaginary parts here. So if we're doing 2 minus 4, 2 minus 4 is -2, and then -3i minus 8i is -11i. So my answer here is -2 minus 11i. This one has a lot more parts, but we still just combine all of the parts together. So 7, -3, -3. So 7 minus 3 plus -3. So this will be 1. And then let's look at the imaginary parts. We have -i plus 4i minus 2i plus 6i. So let's rewrite that. -i plus 4i minus 2i plus 6i. Okay. This is 3i minus 2 is 1i plus 6 more is 7i. So your answer is 1 plus 7i. Multiplying is a little bit more interesting, and for these ones I'm going to use the box method. I'm going to take 5 minus 4i and 2 plus 3i, and then I'm going to use the box method to multiply them. I just wanted to remind you that I squared is -1, and that's going to be important in just a second. So 2 times 5 is 10. 2 times 4i is -8i, because it's negative right here. Okay, that's negative. 5 times 3i is 15i. And then 3 times -4i is -12i squared. Now, this is the part that is important, because remember, we have an I squared right here. And if we have an I squared, then we need to write -1. So what we have in this bottom box right here is just -12 times -1. -12 times -1 is +12. So now when we combine our like terms, we have 10 and 12, and then we have 15i and -8i. So 10 and 12 is 22, plus 15i minus 8i is 7i. So there's our answer. This one I can kind of just distribute through here. So I have 7i times 3 is 21i. 7i times I is 7i squared. And remember that I squared is -1, so 21i plus 7 times -1. 7 times -1 is -7, and so now we should rewrite it as -7 plus 21i, just because we usually write the real part first. Okay, on your practice today, you have some add, subtract, and multiply problems like we just did. You also have some quadratic equations to solve that have complex solutions. That's your practice. I will post an answer key for the practice, but then you also need to get the mastery check done. So go click on the mastery check when you're done doing the practice. That's it. Have a great day. See you tomorrow at the live lesson.